This is section 16 of the ACT Math Manual. Section 16 deals with systems of equations. This starts on page 117. Systems of equations, again, this is a concept that most students learned, maybe in 8th or 9th grade, possibly 7th grade. And by the time they get to junior or senior year when they're taking the ACT, they have some sense of how to handle a system of equations, but they don't know anything much deeper than just how to solve them. And because a slightly deeper understanding may actually help you on some questions on the ACT, we will delve into this possibly a little bit more deeply than we do some other concepts and topics. Now, what is a system of equations? Well, basically a system of equations is simply when you have two equations usually with two variables, and you need to figure out how the two equations relate to each other, whether they have points in common, whether they have no points in common. So there's just two equations that you need to deal with at the same time. In fact, it could be more than two equations. In terms of finding the solution or solving a system of equations, you, again, should understand what that actually means. One is that you are trying to find the values that satisfy both equations. So when you have something like 2x plus 3y equals 7 and maybe 4x minus y equals 10, and somebody tells you to solve this system or find the solutions to this system, they're telling you to find the x and y values that make both of these equations true. The other way that you can think about this is you're trying to find points of intersection between the graphs that correspond to these equations. So these are two linear equations. If we were to plot these linear equations on the xy coordinate plane, we may find, for instance, and this is not necessarily accurate, but we may find that they intersect here. Well, that point of intersection is also the solution set. That point of intersection will be the x and y value that make both of the equations true. So here's a couple of examples of systems of equations. Now, I will say most of the systems of equations that you encounter on the ACT will be linear equations, which we'll talk about below. But a circle and a line could intersect, and remember that a circle and a line could intersect 2 times. A circle and a line could also intersect no times. For instance, if the line was out here. Remember that a circle and a line could also intersect 1 time if we had a line that was tangent to the circle and only touched once. So again, circle and a line could intersect 2 times, no times, 1 time. 2 parabolas could intersect 2 times. So these 2 parabolas happen to intersect at these 2 points, but you could have, this parabola up here and this parabola down here not intersecting at all. You could have parabolas that are tangent to each other. And then a line and a parabola. Again, lines and parabolas could intersect no times as they do as they do not in this figure. They could intersect 1 time. The line could be tangent to the parabola at some point, or they could intersect 2 times. There's 2 points of intersection. So again, what we are doing when we're solving a system of equations is we're finding the points of intersection. We're finding the x and y values that lie on the graphs of both functions, both circles, both lines, both parabolas, and so on. Now, systems of linear equations, first of all, you should know how to recognize both forms of a linear equation. One, the standard form, is ax plus by equals c, and that looks like the form that we're dealing with here. And the other is the slope-intercept form, which most students are more familiar with, y equals mx plus b. So anytime you see a question that has 2 or more of these equations, both with an x and a y in them, you are most likely dealing with a system of linear equations, especially if the question just comes right out and says system of equations. Now, before we solve this one at the bottom of page 117, we are going to talk about some of the outcomes we'll come back to the previous question. Let's talk about what the outcomes can be when we have a two linear equation system. So one situation is the lines could, and I'm not going to go into too much depth here, I'll just point out the scenarios that we're looking at. So one scenario is we could have one point of intersection. One scenario is that the lines could be parallel to each other and therefore we have no points of intersection. And the other is that we have the same line, that the two equations that were given actually boil it down to the exact same linear equation. Now, when we have this situation over here on the left, let me get that entire thing back into the screen. When we have this situation over here on the left, note that these lines have different slopes. This is 3/2 and this is -1/2. You know that if two lines have different slopes, they are definitely going to intersect at one point. That is the only possible scenario that could happen if you have two lines that have different slopes. Even if the lines have very, very similar slopes, they are eventually going to intersect. That was my attempt at drawing two lines that have similar slopes. So let me try that one more time. One line like that and then maybe another line like that. So notice those two lines have very similar slopes, but because their slopes are slightly different, they do intersect eventually. Now, in terms of what we can do to solve a system of equations, there are many, many ways. As you can see, there are 4 listed here. My suggestion would be to be familiar with all of these, to know how to use all of these methods, considering the fact that depending upon the question, one method is going to be possibly more efficient, safer, easier than the others. So we're going to look at several of the methods over the next question. We're actually going to do this question a few times. So first we'll look at the school methods. Most of you might remember hearing something about elimination or substitution or both, hopefully both. Which of the, let's take a look at number 23. If you want to try to do number 23 on your own before I do, go ahead and pause the video. Which of the following xy pairs is the solution for the system of equations x plus 2y equals 5 and negative 2x plus y equals 10? So pretty typical type of system of equations question, very obvious type of system of equations question where they ask us for the solution for this system. So I'm going to go ahead and first things first, I'm going to put these two equations on top of each other. I'm going to stack them. And I'm going to actually use the elimination method. And the elimination method, I'll do both. I'll do elimination and substitution. But the elimination method, what I'm going to do is I'm going to multiply this first equation by 2. So I'm going to put this up here, I'm going to take this away, and that equation will become 2x plus 4y equals 10. And now, when I add these two equations, the way that I do this is I just go one column at a time. So negative 2x plus 2x is 0. Y plus 4y is 5y. 10 plus 10 is 20. Then I divide by 5, and I get y equals 4. So I actually don't even have to plug the 4 back into either of these equations to get my x value because there's only one answer that has a 4 in it, and it is answer choice A. So that's what the elimination would look like. Again, what I did is I multiplied the first equation by a factor of 2. That allowed me to eliminate the x terms, leaving me with only the y terms, which left me with an equation with just one variable that I could solve for the value of that variable. Now, the substitution would look like this. So if I have x plus 2y equals 5, I'm going to solve this equation for x, and I'm going to get x equals negative 2y plus 5. All I did is I subtracted 2y from each side. I get x equals negative 2y plus 5. Now that expression for x can go into the second equation. It can be substituted into the second equation for the x value. So -2, and now what I'm doing is I'm just going to plug this x value, which is written in terms of y, in for this x here. So -2 times -2y plus 5. So I've just taken this and I plugged it in for my x, plus y equals 10. Now I distribute the -2 times the -2y is going to give me 4y. The -2 times the positive 5 is going to give me -10 plus y equals 10. I'm going to add the 10 to both sides. I'm going to combine my like terms here. I get 5y equals 20, which is exactly what I got over on the right-hand side. Y equals 4, and I'm done. Now, obviously, if I did have, so this is substitution on the left. I'll actually write that down, substitution. This is elimination on the right, elimination. Now, if I had multiple answer choices that had a 4 in the y position, obviously I would go back and figure out what my x value was so that I got the right answer. That is the school method, or those are the school methods, substitution and elimination. Those were generally how you were solving a system of linear equations in school. Now, in terms of how you can use the calculator on the SAT, there's two ways that you can use the calculator. The calculator methods would be, number one, if you have it, and a lot of the TI-84 calculators do, and if your TI-84 does not, you actually can, if you're a little bit computer savvy, you can download this app from the TI website. So we could use this app. Okay, this is in the app menu, or we could use our graphing screen. So let's take a look at both of these, and you're going to have to follow along in your calculator here. So and for those of you who don't know that your calculator has this, you're going to be blown away in a second. Prepared to be blown away. So let me go back there, sorry, so you can follow along. So first we hit apps. We find the Polysimul 2 app. You may not have only 2 apps on your calculator. My calculator is pretty clean, so I only have 2 apps. So you may have to scroll down to find your Polysimul 2 app. You can also hit alpha and then the 8 button, which is your P button. Hopefully you can see this little P letter above the 8 button. So if I hit alpha and then 8, it actually will just clear away everything but my P applications, so it'll take me to where I need to be. So I hit enter when I have Polysimul selected. Notice the calculator is telling me to press any key. I press any key. Now the polynomial root finder we actually use in a different section in the manual, but here we're going to use, you guessed it, the simultaneous equation solver. Simultaneous equation is the same as system of equations. So I hit number 2. That takes me into the simultaneous equation solver mode. I have, in this question, 2 equations, so the 2 is fine. 2 unknowns, x and y, so that's fine. The rest of these settings, I pretty much can always keep the same. Fraction, normal, float, degree, all fine. This next tab here indicates that I have to press the button below it, which is the graph button. So I'm going to hit graph, and what comes up is a matrix. And into this matrix, I'm going to enter my coefficients and my constants. Coefficients, so that would be the 1 in front of the x here, the 2 in front of the y, the constant would be the 5, then I have another coefficient, coefficient of 1, and then the constant of 10. So here's how it goes. 1 for the coefficient in front of my first x, 2 for the coefficient in front of my first y, 5 for my first constant. Now I'm in the second row and I'm going to enter -2 for my coefficient in front of my second x, 1 for my coefficient in front of my second y, and 10 for my second constant. So notice I have my coefficients on the left, my constants on the right, and now my calculator is going to do some magic. Boom, which is exactly what we got on the previous question. The calculator just told me that my solutions are -3 and 4. Now, the calculator is putting it in this sort of weird way, x1 and x2. You need to understand that the x1, I'm going to go back to the system by hitting zoom, system, zoom. The x1 corresponds to the coefficients in front of the variable that you put in the first column. So I put a 1 and a -2 in the first column, meaning that first column were my x values. That x1 corresponds to that first column, so my x1, that's my x value. And in terms of the second column, remember I put my y's in that column. The 2 and the 1 were the coefficients in front of my y's, so that is going to equal my y. So I just basically let the calculator do the work for me. The calculator did all the work for me, really. I didn't have to do much except for enter my coefficient. So that's one way that you can do these questions using the trusty calculator. Now the other way is to plot, to quit out a the polynomial simultaneous equation solver. I can just hit 6 here. So what I can do is I can actually plot these two lines. Remember we said these were linear equations. They happen to be in standard form, and graphing in the calculator, when we go into our y equals menu, obviously it requires us to be in a y equals form. So we need to put this into slope-intercept form, which should not be too difficult. So this equation, I just subtract x from each side. I get 2y equals 5. You know what, I'm going to write that in the regular old form. So I'm going to do -x plus 5. There we go. That's a little better. And then divide by 2, divide by 2. So I'm going to enter that into my calculator here as parentheses -x, that's not an x, -x plus 5 in parentheses divided by 2. And then this other equation, little easier to put into slope-intercept form, add 2x to each side, and boom, we've got it in slope-intercept form. We have y equals 2x plus 10. So that is the other equation that I have to enter, 2x plus 10. Now, when I plot these, watch what happens. When I graph these, I'm going to see these two lines, and with the answers in front of me, it actually should be pretty excuse me, pretty darn obvious what the correct answer is, because the only answer that comes even close to where the lines intersect when we're just eyeballing this is -3, 4. 1, 2, 3 tick marks, 1, 2, 3, 4 tick marks up. So we can see from just looking at the screen that we're at about -3, 4. But if you want to do this the very correct technical way, what you would do is this. You hit second and then your trace button, which the second function of your trace button is this calc menu. So we're going to hit second trace, and then we see number 5 here says intersect. So I'm going to go to intersect number 5, and what the calculator is doing is it's asking me to tell it where the first curve that I want to analyze is, and the first curve is this line. I only have 2 curves, so the first curve, I'm going to hit enter on that first curve. Second curve, I'm going to hit enter on that second curve. Some students think that you need to get the cursor near the point of intersection, and you really don't. The calculator will do just fine without getting that cursor near the intersection. So the calculator's asking me if I want it to guess, and I've always found that funny because, like, what else would I want it to do? So I'm going to hit enter, and indeed it gives me that the intersection is -3, 4. So again, you can use your graphing screen and then the second trace button to get into your calculations menu, and then use your intersection calculation. Mark the 2 curves that you want to find the intersection of, and the calculator will do the rest. So those are the calculator methods. Now, last but not least, technically you could use Nidus on a question like this. If you've done that section of the manual, you know what Nidus is, plugging in the numbers in the answer choices. So technically you could take this -3 and this 4 and plug both of those values into both of these equations and see if you get a 5 and you get a 10, and if you do, you know that this is the right answer. If you don't, you would go to the next answer. The problem with Nidus on a question like this is, yes, it would be a little bit time consuming, especially if your answer was E. You'd have to go through all of your answers before getting there. unless you started at C, which is what you're supposed to do on the technique anyway. But yes, it would most likely be time consuming. So Nidus is by far the least efficient technique for solving these questions. Now, creating and translating system of equations, these questions can be tough for some students, not only because sometimes it can be hard to see that you're on one of these questions, so some students just won't know what to do, but translating the actual equation can be a little bit difficult. These questions do show up quite frequently, so if you're going for a really high score, you're going to want to know how to do this and know how to do it well and confidently. So number 19, if you want to take a stab at it on your own, go ahead and pause the video. I'm going to go through it now. The sum of the real numbers x and y is 21. Their difference is 15. What is the value of x, y? So they tell us the sum of the numbers x and y is 21. Well, that is a translation, and the translation yields one linear equation. And then the next phrase, so that was our first phrase, this is our second phrase. The next phrase does the same thing. X minus y, their difference is 15. So again, I translated the first phrase into an equation. I translated the second phrase into an equation. I now have two equations. What I am going to do here is very simple. I'm just going to add the two equations, and I'm going to make my sign really big so that I know that I'm adding as I go from column to column. I'll know what operation I chose. X plus x is 2x. Y, positive y plus negative y is, that's fortunate, 0. So the y's just go away. They add to 0. And then 21 plus 15 is going to be 36. So now I have this nice simple little equation that I can solve for x. So I know x has to equal 18. And then I just substitute this numeric value back into one of these two equations. I'll do it in the first equation. So 18, which is my x value, plus y equals 21, minus the 18, I get y equals 3. So I know that my x value is 18, my y value is 3. They are asking me for xy. 18 times 3 is 54. And I could check that in the calculator if I needed to. Now, obviously, answer choice A is a little bit of a trick answer here because some students will get the value for x and they'll jump right at answer choice A, which is why it's extremely important to circle what they're asking and pay attention to what they are asking. So the answer there was D. Now, number 11, this is sort of what I was talking about when I said sometimes students don't even realize that they're facing a translational system of equations question. You can take a stab at this one on your own if you'd like. Pause the video. The cost of a hamburger and a soft drink together is $2.10. The cost of 2 hamburgers and a soft drink together is $3.50. They want cost of a soft drink. So again, this is just a translation. Cost of a hamburger, I'll call the hamburger H. Cost of a soft drink, I'll call the soft drink D. So hamburger plus soft drink equals 2.1. Cost of 2 hamburgers and a soft drink, so that was the first phrase. Cost of 2 hamburgers and a soft drink together is $3.50. So that is 2 hamburgers plus soft drink equals 3.5. Now, from this point, I could use the polynomial simultaneous equation solver. I could graph these as a y equals mx plus b, but I think the easiest way by far is to do elimination here. So what I'm going to do is, there's a couple ways we could go. I'm going to actually multiply this first equation by 2. And the reason I'm going to do that is I want to get rid of the H's. They want soft drink. So I wanted these were supposed to be D's. I just realized that must have been confusing. Sorry about that. Sorry about that. So let me get rid of these. These should have been D's. That's my fault. Hopefully you didn't get too thrown off by that. S, soft drink, S, same sort of thing. Anyway, so I'm going to multiply this one by 2. So 2, and then this would become 4.2 over here, 4.2. So I'm going to get rid of this and write 4.2. So again, I just multiplied that first equation through by 2 so that now when I subtract the two equations, These two go away. 2d minus d, well, that's nice because now I just have d alone there on the left. And then 4.2 minus 3.5 is, I'm going to use the calculator for that. I don't even want to waste time trying to figure out what it is in my head, and I don't want to make a careless mistake. So 4.2 minus 3.5, whoa, calculator. 4.2 minus 3.5 equals 0.7. So the cost of a soft drink is 70 cents. They must have written this question back in like 1960 or something. Maybe 1980. I don't know. Whenever soft drinks were 70 cents. They ain't anymore. That's all I know. So answer choice C would be the cost of a soft drink. So again, we translated each phrase into an equation, and then we saw that we had a system of equations. We used elimination to get rid of the H's, and we solved for D, which is what the question was asking us for. Next, we have infinite solutions. So occasionally a question will ask you about infinite solutions, and usually the easiest way to handle these questions is to think about what we talked about before, which is that infinite solutions means we're dealing with the same line. So if you ever see two linear equations and you notice that they have the same y equals mx plus b form, in other words, same slope, same y-intercept, you know you're dealing with the same line, and therefore you have infinite solutions because every single x and y value on those two lines will satisfy both of the equations since they're the same darn equation. So here's how you would handle a question like number 32. If you want to try it on your own, feel free to pause the video and give it a try, although some students do struggle with these, at least at first. So in terms of number 32, for what value of A would the system of equations below have infinitely many solutions? So the way that we would want to interpret it is what value of A is going to make these two equations identical to each other. Here's the best way to do this, in my opinion. So first things first, let's put both of these equations into y equals mx plus b form. So the first one, I'm going to add y to both sides, and I'm going to pull the 6 over to the left. So I would get y equals 2x minus 6. If that confused you, then just write out your steps. Hopefully you will see it. And then this second equation, what I'm going to do is I'm going to add the 2y to get it over here. I'm going to subtract the 2a to get over here. So I get 4x minus 2a equals 2y. Then I can divide through by 2. All of these have a common factor of 2. I can divide through by 2 to cancel that factor. So I get 2x minus a equals y. So now lining these up, I get y equals 2x minus a. 2x minus a. Well, should be very clear to see that if I want these two equations to be identical, if I want them to have infinitely many solutions, then my a just has to be 6. And that's how I solve a question like this. That should have been circled, what value of a. So that's how you solve an infinite solutions question. Put them both into y equals mx plus b slope-intercept form and play a little game of matchup. See what you would need in one equation so that that equation would match the other. Now, in terms of no solutions, remember that we talked about system of equations having no solutions when the two lines are parallel to each other. In other words, they never intersect, never have points in common. In that case, what you would need to do is find values that would make the slopes equal but the y-intercepts different. So here's a xy coordinate plane. So notice these two lines have equal slopes, but their y-intercepts are different. So again, for no solutions, same slope, different y-intercepts. For infinite solutions, everything's the same, the slope and the y-intercept. That is it for system of equations. If you feel like you need further clarification, obviously, as I always say, talk to your tutor or do a little bit of review on your own. We went through a bunch of different ways to solve simultaneous equations here. Hopefully your calculator has some of the capabilities we talked about. If not, you're going to have to use elimination or substitution pretty much solely as your only method of solving these guys, or you can get a new calculator if that's an option for you. And I think that's about it.